Or if you're looking at the internet, for instance, it uses light to transfer information from one place to the other.
Wait, so the internet uses light how?
So there's things called optical fibers.
Yeah.
So in the past, how we used to transfer information was we used to send little particles called electrons down copper wires.
Okay.
And you would see copper wires overhead wherever you drive.
Everywhere, yeah.
But now what we use is a particle of light, which is called a photon. And we can send this particle of light down an optical fiber.
Welcome to Let's Talk Science with Tuli, where we connect science to you, the people. And apparently you guys think scientists and engineers are boring and they're inaccessible, but really what scientists and engineers do is try to understand some of the world's most pressing challenges. And these are challenges that affect me, that affect you, that affect the world. And really what we're doing at this podcast is just having casual chats about what it is they do, why they're doing it, and how it affects you and why you should care, you know. And today I'm very excited to have Dr. Darryl Naidoo, who I used to work with before when I was doing my master's in biophotonics at the CSIR. Welcome, Darryl. I'm so happy you could make it.
Yeah, thank you for having me, Tilly.
That's lovely. Darryl, just a little bit, where are you from?
So I'm originally from Pietermaritzburg in KwaZulu-Natal, but now living in Pretoria. I've been in Pretoria for the last 12, 13 years.
Sure. And did you study in Pretoria? Did you study undergrad in...
So I did my complete undergrad at UKZN. I did my honours there, and then I did my master's and my PhD based at the CSIR, but I was registered master's at UKZN, PhD at Stellenbosch University.
And these are qualifications in maths and physics?
So this is a complete qualification in physics, with a specialization in lasers.
In lasers, and holistically or rather globally, then that's termed photonics, right?
Yes.
What is photonics?
So photonics is the study of all things that is light.
Okay.
So if you are studying the rays from the sun, for instance, or if you're looking at the internet, for instance, it uses light to transfer information from one place to the other.
Wait, so the internet uses light how?
So there's things called optical fibers.
Yeah.
So in the past, how we used to transfer information was we used to send little particles called electrons down copper wires.
Okay.
And you would see copper wires overhead wherever you drive.
Everywhere, yeah.
But now what we use is a particle of light, which is called a photon. And we can send this particle of light down an optical fiber. The optical fiber basically traps the light as it travels down the fiber.
Oh,
So I'm able to I can pack information into one photon, and I can send that photon all the way down this optical fiber, and then I can detect it on the other side to know what it is.
What kind of information?
So basically, when we think about the internet is a stream of information that's running down optical fibers. So there's little packets of information in all different parts of light, in different colors of light, and when they propagate down and when I detect them, then I know basically from what I've sent to what I receive is exactly what I'm expecting it to be.
Okay, so I am Googling something. I'm Googling Let's Talk Science with Tuli.
Yeah.
I am in, I don't know, wherever I am in the world. I'm in Uganda.
Yeah.
You know, how does that translate to what you're saying?
So basically you would go into a search engine, and it's a lot more complicated than I'm making it out to be.
Yeah.
But basically you will, like once you search on Google, for instance, you are calling up a certain amount of information.
Yeah.
Right, so you will ask your package to give you a certain amount of information, and as soon as you type in stuff, right, you find that your Google search bar already gives you options.
Yes, yes.
So it's honed down the information already that's in a server.
Yes.
So it's almost like if I have a computer and I've got a bunch of files, The moment I start typing for a certain name of a file,
Yeah.
then I'll get a list of options.
Yes.
So basically that information will sit on a server or sit in the cloud,
Yeah.
as they call it. And once I'm able to get it through there, then I'm able to select the information that I want.
Yeah.
But that data transfer comes from various different servers around the world. And if I want to send information from one point to the other, then basically, for instance, if we think about downloads,
Yeah.
if I want to be able to download some sort of information, basically when we look back at the fundamentals of what information is, it's known as bits. So it's ones and
that's
zeros.
true. Yeah.
And
yeah.
they're packaged in a certain way.
Yeah.
So when I'm downloading the information, it'll come to my computer as bits, and then it'll repackage itself into the information that I need it to be.
Okay, no, that's fascinating. That's really awesome. And then what you guys are doing there at the CSIR is what exactly with photonics?
So specifically with me, I'm a laser scientist.
Okay.
So I look at designing customized laser systems. Now, typically the laser systems are aimed toward industrial manufacturing. So ideally what we want to do is we want to use different types of lasers, different colors of light, also known as different wavelengths.
Okay.
So if you've seen red laser pointers, green laser pointers, those are called different wavelengths because they have different energies.
Yeah.
But they're also, colloquially we can just call them different colors. So we basically design these kind of laser systems to be able to use in industrial manufacturing. Some of our main application areas that we're focusing on is laser cutting, laser welding, and a very hot topic of 3D printing, otherwise known as additive manufacturing.
So 3D, industrial manufacturing, so in other words, people that make cars, for example, then they'd ask you to make a specific laser for them.
Well, in principle, so our research is based on trying to make customized laser systems to make them more efficient in the process. So at the moment there's a bit of an industry standard on what people use. And it's not necessarily the best solution for what you're looking for.
Give us an example for an application of a laser that is not efficient and how it could be made more efficient.
So I think a very good example in this case is additive manufacturing. Now 3D printing takes a very complicated computer model, and you're then able to melt, and in our case what we look at is we melt powders.
Okay.
So we basically have a very thin layer of powder, you melt it according to the design.
Using the
a
heat
laser.
from a laser, yeah.
You then put another layer of powder, you then melt it again, and you keep going through the layers that correspond to your design.
Until you have
the full
the
part.
cup that you have as the design.
Exactly.
Right? Okay.
But now if I had to think in a very difficult situation, if I had a really complicated part where my heat distribution that comes from the laser needs to change as I'm melting, it's a little bit, it's a bit strange. You think to yourself, well, the heat distribution that I have from my laser
is consistent.
Is going to be consistent, but I might need it to change to make sure that my part is stable.
So that your part doesn't melt.
So that your part doesn't break in certain areas, that the stress in certain areas is completely 100%.
Then in that point, in that case, you then have to make what a laser that like a tunable laser.
Effectively, yes. So then you make it tunable so that your heat source can dynamically evolve as it's moving across the part. Now that dynamic evolution is what is known as laser beam shaping. So laser beam shaping, very typically, if I shine a laser pointer onto a wall, I will see a little round dot.
Yeah.
But that gives me a specific heat distribution or temperature distribution that goes onto my material. That's not always the most desirable.
Typically with the circular laser, you've got like a lot of the energy centered in the middle, right?
Yes.
And then as you go out in the periphery of that circle that represents the laser spot, you get more and less energy. Okay.
We can actually think about it as a bell.
Yeah.
If you look at a bell, the energy in the center is very high, whereas the energy on the edge is very low.
Okay.
And sometimes that causes a lot of problems in processes. Because if you want your energy to be constant, you can't use that type of laser beam shape. So the work that I mainly focus
I
on
see.
is transforming that bell shape into something that looks different. So we can transform it into something that looks completely flat, like a square or a flat circle.
Where the energy is distributed evenly, perhaps.
Is distributed evenly.
Aha.
We also look at beams that are commonly known as donut beams because they look like a donut.
Oh yeah.
A little
yeah.
hole in the center, but they've got very specific properties in how the beam moves from one position to the next. It propagates like a spiral. And so when that property is added onto a melting process, it changes your actual process. But it also makes it more controllable. So the idea that we're working on with these customized lasers is to now shift and change our laser beam and be able to do it in such a way that that temperature distribution on the thing that we're melting can be varied in a certain manner.
And where do we apply perhaps a laser of that nature in like daily life perhaps? How could that laser increase the efficiency of anything?
Well,
other than 3D printing.
Yeah, I'd say generally one of my favorite application areas is either in the medicine or in aerospace. Those two areas specifically require very, very high value complex parts.
Yeah.
I mean, there's lots of studies, and there's a couple of universities in the country that do what is known as a mandible transplant. So the bone that sits here in your jaw.
Yeah.
And there's a certain disease that eats away at that, or if you have a birth defect on your jaw, then what they do is that they map out your face, and they map out exactly, because everybody's mandible is different. It's one unique thing that we have in our bodies, is the shape of our jaws and our mouths and stuff like that are all different. And what you have is with this mandible is that you do a scan of the person's face to identify what that mandible should look like. And it's a very complex part, very difficult to build, but you can't do it using conventional manufacturing. Conventional manufacturing would be using a saw and a milling machine and things like that, right? But in 3D printing, you can basically get this beautiful part that you can make. So that's a really wonderful application that I feel it can make really complicated things. I think actually in the university, I think it was the University of Pretoria, where there was a professor that did the first inner ear transplant using a 3D printed inner earpiece.
Oh, nice.
And when you're looking at these high value components, you know, when you look at customized lasers, they will eventually be used in almost all walks of life. Even when you look at data transfer, communication, simple things like laser cutting, for instance, there is a limit on how thick you can cut a piece of steel, right? And I mean, typically industry standards go between, let's say, 3 and 6 or 7 millimeters. But if you change the dynamics of your laser beam, you can actually cut it down to 25 millimeters.
Because, I mean, lasers are characteristically more precise.
Exactly.
Than a scalpel or like a physical thing that you could use. Oh, that sounds cool.
But I mean, lasers are just, they're used absolutely everywhere. If we think, I mean, let's talk light in general. Probably light is one of the most important facets we have on Earth.
Absolutely.
Without the sun, we would have no life. And that's already just direct light. But in many other different areas that we're currently focusing on, photonics, lasers are playing such a big role that when we look at the 20th century, it was all about electronics.
Absolutely,
Like DVD players, CD players, hi-fis, all of that was
but
electronics.
all of that had lasers though as well.
Eventually lasers started coming into it.
Yeah.
But it was mainly based on electronics.
Okay.
Now the 21st century and above is going to be based on photonics.
And that means you can also make your devices smaller, right?
Smaller.
Because electronics also have a heavy element of hardware, right?
Yes. I mean, if we take something very simple like our cell phones, I mean, we use them absolutely every single day. We cannot live our lives without them anymore.
Unfortunately.
But there are probably about 50 different processes that lasers are used to make a cell phone.
Oh, yeah?
There's a whole host of different processes.
And are these different lasers that are being used for the different components?
Yes, yes.
And what if I understand you correctly, you're saying, I come to you as a client and I say to you, well, I want to be able to develop, I don't know, a knee. And there isn't a laser right now that has the properties to be able to develop a knee, and then you would develop that for me.
Yeah.
What is the process of developing a laser?
So the very first process is understanding the application. That's the most critical part. It's almost like you want to start at the end and then move your way back to the beginning. I've heard that's the best way to tell a story.
You start at the end.
You start at the end and then you go to the beginning, and then it builds up.
Yeah.
But basically you will start at your application. The idea is to understand the application needs first. So there's a certain type of analysis we use. So the first one is the need. You know, that is your application. The second part of it, you will then identify, okay, what is available to do this? And you have a look and you're like, okay, there's nothing currently commercially available. Is there something in research that can be used to do this? Then you've got to go and do a whole lot of literature studies and stuff. And once you've gone through that process, you understand your need, you understand your application, you understand what's commercially available, what's scientifically available, and then you decide from there what is the best route for you to go moving forward.
Okay. Okay, and very briefly for the person that doesn't know, what makes a laser?
So
as opposed to normal light.
Just the sun. So there's three distinctive things that differentiate a laser from the sun. The sun, the light from the sun that we get is called white light. So it's made up of lots of different colors of light. Whereas a laser is only a single color. It will only ever be one color. Lasers are known to be very directional. So that means that if you take a laser pointer, you can easily shine it across the room.
Yeah.
But stand at the same position and open up a torch and shine the torch into the wall,
it will diverge.
It diverges very, very quickly. And the third thing is that lasers will carry different types of energy.
Yeah.
Depending on their colors. So basically they are monochromatic, so they're one color.
Yeah.
They're highly directional. You can point them into a certain way. And all of the waves are moving in a very specific way.
And when you say waves, you mean like that wavelength that you were talking about, that's characteristic of, colloquially, the color of the laser. Okay, cool. And then I can definitely see and I can hear how lasers are a very important part of our lives. Even though we're not necessarily aware of it, they probably are when we're shopping, when we're taking a picture of something.
I mean, barcode scanners.
When
you're taking a picture, you're using optics.
And optics
and it's all part of the global thing of photonics.
How do optics play a part? What are optics?
So optics are, it's almost like physical devices.
Yeah.
So if you wear spectacles, the lens that's in your glasses, that's an optic.
The camera is an optic.
The camera's chip is part of an optic. It's more electronics actually, but you'll get the lenses that fit on the outside of the camera that makes it that's an optic.
And how are they important for photonics? So
optics are used to transfer light from one place to another.
Yeah.
So I can use lenses to focus light. You know, if at any point you were a kid and you ever got a magnifying glass, one of the first things you would do is try and go and burn ants.
Absolutely.
Right? And that's
because you're focusing the light from the sun.
Because you're focusing the light from the sun.
Yeah.
And so optics are used to manipulate and transport light from one position to the next.
You can direct light.
Exactly.
Using optics.
Okay. And if we look at normal cameras, for instance, the light that we see is just actually the ambient light. It's the sunlight. So there's always some light involved when you're working with optics. If it was completely dark, you wouldn't need optics because you wouldn't be able to see anyway.
Yeah. Okay, no, that's awesome. I think even our eyes are...
That's the perfect optic, actually.
Yeah.
The lens in our eyes are known to be the perfect optic. Because that lens has got to be able to change its shape when you're focusing at a further distance or at a shorter distance.
Or when it's darker, or when it's lighter.
Darker, when it's lighter, the iris opens and all of that. Unfortunately, people who need specs don't have the perfect lenses.
Absolutely.
But for the majority, your eyes are the perfect optic.
And that's photonics, folks. I mean, it's definitely it sounds complex when you're like, oh, I have to do a master's and a PhD in physics. But when you think about it, optics and photonics, they're everywhere, every day, and we use them for so many different applications, like Darryl was explaining. And I certainly learned a lot from Darryl in terms of understanding how photonics and the research that they do at the CSIR, where photonics is concerned, relates to my life and how it can make my life better, or advance society and advance industries and make systems more efficient. And I hope you got the same out of it. If you do have any questions, do send us comments below and ask us anything, and we'll try to respond to you guys. But that was really exciting for me. And that's the end of our Let's Talk Science segment. And we're going to speak to Darryl in our #BeyondScience segment, where we find out what he's doing when he's not staring down lenses and figuring out what the distribution of energy should be. So I'll see you guys after this. So at least if you're listening, tune in after this. Ciao, ciao.